Hello. So last time we discussed assignments and how we modeled and implemented time through our through our system. So now variables can change through time. And one of the concerns that we had is how concurrent systems will get affected by this. And one of the big problems that we could have, sorry, let me just skip to the next slide, is one of the big problems that we can have is having multiple threads trying to access the same variable, which keep in mind that variable, as we said, can change through time, which makes, for example, two threads trying to access the same variable, and while the first variable trying to read the value or trying to process the value of that variable, another thread changes the value of that variable. And here we have like a race condition between multiple threads, and it can go deeper than that, which is like interleaving. And basically, the first thread read the value of that variable, and while trying to change that variable with relying on that value, the the second thread change the value of that variable in the middle of that process. So now we have a thread that is changing the value of that variable, relying on an old value rather than a newer value. And this will lead us to have inconsistent results in our programs rather than a consistent logical result, and could lead to a corrupted or hard to debug problems. And one of the solutions that or the solution to resolve this problem is you can we can call it state locking, which is basically locking the state of that variable whenever a thread is working on it. So this would resolve our interleaving or race conditions that we have through our threads. So whenever a thread try to access a variable and change it, it will lock the state of that variable. So so in case another thread to try to access the same variable, it will be locked to be accessed through any other thread until the first thread that was using it finish it will finish use it will finish using it. Then it will unlock the state of that variable, and it will leave it for other threads. As much as this solution resolved the problems that we had, it did introduce new complexity and new risks or problems in our system that will lead, let's say, a very cognitive consuming energy to build our programs. One of the big problems we have is like deadlocks. So assuming that we have two threads that trying to access two variables, A and B, and the first thread access the variable A first, and the second thread access the variable B first. And they need to complete their processes, they need to access the other variables. So the first thread will need to access to variable B, which is locked by the second thread. So it will wait for the second thread to finish. But the second thread to finish, it also needs to access the variable A, which is locked by the first thread. So here we have like a conflict or a paradox problem where each thread is waiting for the other to finish, and no one is going to finish because each one is waiting for the other. And this is one of the problems that we have. And to resolve it, we could for example uh, make the log uh, state or the log variable in our local objects uh, to up a notch to another level, which is, let's say, global level, where it can be uh, shared between multiple threads. And now we can have whenever our thread can run, it can know like the variables that it will use. And it will lock them before the other thread locks one of them. But as I said, the adding this lock, this lock-in solution did introduce us to another level of complexity that we need to keep in mind whenever we build in our programs, and which will make building our programs and our system inconvenient. And that's what I want to discuss in details is uh, I would call it like a flaws of the way we modeled our system now, which is like and by modeled our system, I mean like modeled time in our programs, which one of the concerns is that we modeled it in a human thinking way rather than a computer way. And as much as we want the computer programming to fit the human thinking, but this did the opposite. It's made the building programs more complex for a human thinking perspective, and it's made it more cognitive consuming. And here where I want to jump to another solution that could replace the assignment solution, ki- knowing that assignment solution is a way that we model time with it. Um, so what are streams? Streams is just a data structure, and we we can assume that it is like a sequence data structure where it only gives you the first value, and the other values they stay unprocessed or uncompiled, or yeah, let's assume that they say let's define it as unprocessed, and whenever you call it, then it will run the next value, will give you the next value, and moving on. And the sequence of those values can be defined depending on a procedure and of arguments, and how you want the other value to be executed depending on the first value that we have. So you would ask how can we change assignments with streams, which is like just a data structure among all other data structures that exist. But uh, imagine that in our first time modeling where we have like a variable and it has a value, and whenever we want to change it, we remove that value, erase it, and we put the new value. So while having this as a as a way, it it does lead us to a constraint of time in our solution. But if we imagine that our variable is a does have all the values that can have through the future as a sequence, but they are uncompiled, but they are in process, but they exist, all of them, all the values that we want that variable that variable will have in the future, they exist, they're just unprocessed. And this is where sequence comes and change the variable from a mutable object where uh, it can change through a time to an object that is timeless, that has all the values that can have through time. And from here, we did remove time in from our constraints and made our object timeless, since it has all the values that it will have in the future. They're just unprocessed. They exist there, but they're unprocessed. And from there, we 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 did resolve our our most of our problems that we have. We still have some. We didn't resolve all our concurrency problems. We still have to manage the order of the threads uh, on each variable to use. But the main problem that we have where we get like inconsistent data or a corrupted data, and the way we resolve it, where we have more complex programs that we need to resolve, that it's became more, now we have like a more human thinking problem, that human thinking system, that we don't need uh like uh, a big cognitive energy to build, since streams did resolve like all the time issue that we had. And uh, now we only need to think about uh, the variable as uh, a timeless object that won't change through time, and from there we won't have a problem in I'm sorry, I'm going too far with this, but I think you understand the point, what I mean by uh, removing the time from our objects and making the variable as timeless. And here I want to discuss uh, how does, like, from the scenario that we talked about earlier, how does like modeling our systems and our programs affect us? Like, we had, when we did model the time in first way as a instant change, where we erase the first value and add the newer value, it did introduce us, and uh, created more complex and bigger problems that we need to manage to to uh, to create or build our programs. But when when we build or we modeled our program to fit or to support time, and uh, as much as to support the how computers uh, let's say think or uh, evaluate or compile our code, then we did have a more powerful way to build, which which made the programming more easier and self-managed by variables that became uh, independent through time, and at the same time still can change.